go back to basics for the risk management process. So it's kind of understanding what are real risks. This is a typical little example. So the manager calls in the risk, or the exco member, let's call him the boss. He calls in his little risk manager, or his risk champion. He says, okay, we're going to do this project. Just here you go, just go and do a risk assessment for me. Now firstly, the risk manager doesn't do a risk assessment on their own. They have a forum, so they have each discipline there. They have engineering, procurement, design, detailing, construction guys. They have everybody around the table, commercial, and they say, well, what do you feel poses a risk? But this manager, this exco guy, this director, he just said, you just go and do the risk assessment for me. So this guy's going, and he's just putting his own little risks down. He's saying, oh, indecisiveness, over-analysis, cluelessness, and micromanagement, they are all risks. And then he goes back to the director and he says, well, yeah, I did the risk for you on the project. And he says, well, I don't understand these risks. The risk champion says, well, if you refer to risk number 36, that we knew the risk was that you weren't going to understand it, right? So the problem is, do we ourselves know what a real risk is? What is a real risk? So what I want you guys to do is, so which of these are real risks? So I want you guys just to take a second. There's 5 of them. So I've put down schedule delays, cost impact, injury or fatality, inclement weather, and instrument failure. So give it a bit of thought, and then I'll ask you guys, who of you think by show of hands it's all 5, 4, 3, 2, and then we'll go down. So if you had to think, what of those are real risks? So, and don't be shy now. I mean, the masterclass is here to learn, so I don't expect you guys to know. It's like if you would ask me, if you're a civil contractor, how much concrete to pour, I'm also not going to be able to. I'm also going to guess if I had to put up my hand. So who of you think all 5 of those are real risks? Okay, who think 4? Okay, 3, 2, 1, none. Okay, interesting. Okay. We should have actually made a bet on this. We might have been rich after the session. So only one of those is actually a real risk. And it's instrument failure. That's actually the only real risk there. And I'm going to explain why. So if we look at schedule delays, cost impact, injury or fatality on site, that's a consequence. So if the risk happens, we're going to overrun on schedule. It's going to cost us more money, or we might actually have an injury or kill somebody on site. And we can debate this. Really, we can, because it's very interesting, because then if my understanding is why you guys would think they were real risks, we can also discuss it and try and see if we can work through it in how do we identify the real risks. The 4th one is a cause. So if I would say the risk is inclement weather, lots of rain, lots of wind, I'm not understanding what the risk is in inclement weather. It's a cause. It's because it rained a lot, or the wind is, we can't lift because the wind is about 15 kilometers or whatever the OSH Act says. So what is the risk? What do we face if we have adverse inclement weather conditions? So it could bring civils and earthworks to a halt on site, for example. If we decide not to mitigate and say we're going to weld in cocoons, because we can weld in cocoons, so we might say, well, welding could be affected. The real risk isn't the inclement weather, but are you guys kind of understanding what I'm saying? I would tell you the real risk is inclement weather or rain or wind, and I say, okay, what's the cause to inclement weather? What's your answer going to be? So godly act, or I don't know. So, and then if we mitigate the cause, how do we mitigate, and I'm a Christian, how do we mitigate God? I mean, so, and you guys laugh, but that's the way I usually sit with the construction guys, and I love the guys I work with because after 4 years, I don't have to do a lot of explaining. They just come to me with all the real risks. But you guys see how important it is to get to the core of the real risks. Because from there, you'll know what your causes are, and then we'll know what to mitigate. If we don't have the real risk, and sometimes a lot of people will say the consequence or the cause is the risk, and there's nothing wrong with it, but what I want you guys to do is in future, if you think of, just wonder if this is really a real risk, and all you have to say is that, for example, let's choose one, injury, fatality, that's the risk, I think. Then just ask yourself the question, okay, well, what causes? So if that's not a consequence, that's a risk. So if we have an injury or fatality, what would the consequence be? Or what would the cause be? So usually injury or fatality is the consequence of us not mitigating the causes and looking at the exposure of the risk. Same with if we say schedule delays. So we say we're going to overrun on schedule. It's a very broad risk for a construction site. Because what do I mitigate in schedule? Overrun. Because I don't know what I'm going to overrun in. Am I going to overrun on procurement? Am I going to overrun on construction? Am I going to overrun on time because I don't have enough resources on site? Or because of a strike again? So if that was the real risk, how do I mitigate it? So do you guys understand what I'm trying to say? And if there's anyone that doesn't, because this is the core of risk identification and how to manage it, then you guys, please, you're more than welcome to ask me a question. So yes?
I suppose instrument failure, that's a big risk, but I think it could also be seen as a consequence, because then one would ask, I do appreciate that we're talking about this in the construction industry, in the context of the construction industry, but the instrument in its own self, I mean, if you're talking to a guy who works in a lake factory, or in this instrument failure, then that is a consequence of perhaps wrongful usage, lack of some certain thing, timelessly and properly, and using proper parts and services. So then it's a consequence of a whole lot of other causes.
Won't that maybe be the consequence? So if I'm understanding you right, so you say, let's say the instrument failed because you used the wrong equipment, or are you saying that it wasn't fit for purpose, or what was what do you?
The person operating the machine doesn't know how it has not been trained properly to operate the machine. Machine operator did not show up. They quickly got some time to shred it, to screen.
So let's say it's around the training of the operator, right? Let's run with that one. So we say the risk is that because of a lack of understanding of the operator, the instrument might fail. If we use that one, you're saying that's the consequence. And the cause would be lack of management in training, or not appointing people fit for purpose. Just for example, because we have to treat the cause now, right? But let me just put a spin on it, and if I say to you, the cause is because the guy wasn't trained how to operate the machine. So the cause is he doesn't know how to do the job. The risk is that that cause is going to pose the risk of the instrument's going to fail then, because he doesn't know how to do with it. So this is basically going to break the machine type of thing. The consequence is downtime. So that conveyor belt or that part of the factory is going to stand until we replace it, for example. So I'm going to ask you the question differently, in the sense that if we as a team, or a project management team or company, if we had to look at mitigations, so the one cause was due to management training, and the other cause was the guy not knowing how to operate the machine. If a company would identify the risk that the cause is because management's not training their people, that's already a red flag and a concern. Do you understand? Because they mean they are just appointing people, and your instrument failure, the risk there is, the consequence on that might be that you might injure one of your people, or you might have a fatality as well, because you're not training them how this works. I worked we were fabricating structural steel, a bit off the point, but to get to your point, for the Medupi power station, for the air preheaters. And they have these little rollers that the plates go through, right? Same when we built the cans for the flues. So of course they roll the plates and then they bring them together, dog and tag them, and they start welding them, right? So the guy was standing between the roller because they can fit into them, and it was actually busy cleaning. And there was an operator on the other side. Now the first thing you always have to check is the machinery safe for use, etc., etc. It's all to do with training again. That guy switched on that machine and he didn't know those guys were in between the rollers. Of course, the rollers sucked the guy in, and unfortunately the guy died on the scene by the time we got there, and the paramedics was too late. So the consequence could be that we could even injure or kill somebody, right? So I'm just thinking, if we take it a step back, that is the real risk really because the guy's not trained? Or are we going to specific saying the real risk his instrument might fail because the guy doesn't know what he's doing? And you can play it both ways, 100%. Then my question would be, if we would mitigate causes, is it easier to mitigate the fact that the guy's not trained, we can send him on training? Or is it changing the mentality of a management team saying, you're just appointing guys and you're praying for the best?
These causes are many of them. You can set aside for injury or fatality, and these causes which you mitigate, then the risk of injury and this consequence of injury is the same.
But injury and fatality is, what would the end product be if we don't mitigate the risk? Because if the risk is injury and fatality, what would the consequence be?
Cost of delay. Cost of somebody's death.
Okay, so the risk is injury and fatality. So how do we mitigate that? I'm just asking because there's different spins on it, and I need to get your guys' input.
You look at the causes. You did a root cause and said that one of the causes is bad training, and you didn't train people better, appoint competent people, or management failure, or whatever it is. I mean, those are the causes of injury and fatality.
Well, from a project risk management point of view, we would say injury and fatality as a consequence. If we don't mitigate risks and we don't look after, for example, our people, then we could kill one of them, for example, on site or in a factory shop. And you can play it either way. If you do get to this dead halt, and you're 100% right, because this is a lot of things that we face, is, well, what is actually the real risk? What's the cause and what's the consequence? Is unpack them in various scenarios. So take it as a real risk, take the risk as a cause, because you can unpack them. And then start focusing on your treatment and your mitigations.
Sorry, did you say injury and fatality is a consequence? Because and I remember in your initial slides, the ultimate consequences, you split those in two ways: schedule delays and the cost impact. So then we are now saying is.
Yeah. So for example, if we have a big construction site, or your factory, for example, right? That guy runs one conveyor belt, right? Makes little milk carton boxes. Let's just, for example, say, right? So he just runs this one thing, and that guy gets injured, or he's the fatality. It won't bring your whole plant to halt, will it?
Sorry, but in a construction site, for instance, once you get an injury or fatality, you pretty much cut the whole site down.
Yeah, so in some circumstances, yes.
So the schedule and cost delays to the project because of this.
Yes. So how would you mitigate?
It then goes back. Why was the fatality or injury? What were the causes? And then you look at what caused the injury.
Okay.
Then you would look at trying to mitigate it. You would look at trying to make sure that the right procedures are in place for a fatality when it does occur. But you also then have to look at the exposure on the entire project. Perhaps an injury or fatality on site that the correct procedures were followed. If that happens, the downstream to that is that you're not going to have the whole site being shut down.
You just have an
The
area.
exposure might just be one section that needs to be.
Yeah. So it's very little that an entire shut, and help me if I'm correct, because you guys have worked on various projects as well, is I've only worked on sites if there's a fatality that area is closed off pending investigation and the rest goes. I know of multiple fatalities where they will come and they'll shut the whole site down.
Never make the DMO.
But it's mining, 100%. There's an injury, shut all mining down. Mining is a different ballgame, I have to agree. Fatality, injury, managing, they are very important. But from my experience, what I've studied in my field, that's the real risk. And like I said, it's debatable. Everybody does their risk registers in their own ways. What I'm just trying to say is before you guys just put risk down, causes and consequences, just think a step back. And saying, if I think this is the risk, what are the causes and what's the possible mitigations? But otherwise, if this would be the cause, what is the actual risk there too? Just maybe think about it a bit more. But we'll come back to that one. So how do we usually establish what a real risk is? And then we'll break after the slide. So basically, it's because of something that the risk event occurs, which is the uncertainty, okay? And then it has an impact or a consequence, or a possible consequence. Not all risks. We'll always say that there will be a consequence, but it's not always to say that the impact will materialize. You might recover on schedule, you might have risk contingency to pay, so it won't affect the budget. So it's not always to say that it will negatively impact or have a negative consequence there too. So a cause is a fact or a condition. It's something you know. Okay, so because of inclement weather, we know it rains, we know the wind blows, we know all these things because it's a known. We know we face that in construction environments. We know that we might injure somebody or kill somebody on site or in a factory or production plant. Because why do we know it? Because it's happened before. We've had injuries and fatalities before. It's a known. We know it happens. We know we face inclement weather on construction sites. It's things that's a fact, it's a condition. It's what we're aware of. It's what we live with every day. It's the same with if you get in your car every day. We're all exposed to risk every day. So it's a fact that if I get in my car and I drive 160 kilometers down the highway, that firstly I'm over the speed limit. Secondly, people make accidents at high speed. Thirdly, accidents just happen, Joburg, whether you drive 20 or 160 at the end of the day. It's a fact because there's lessons learned, it's happened before, etc. The risk is the uncertainty. The risk is if I drive 160 and I get in a car accident, will I die? Will I be paralyzed? Will I actually be lucky and I wouldn't have broken any bones, just a bit bruised and battered? Upon impact of an accident, the uncertainty remains. What are you exposed to? What risk? Because if we knew, if risks were like causes, it was a fact, it was a condition. If I knew that if I would get into a car accident and I'll be paralyzed for life, I'll tell you, I'm not going to drive 160 ever. Never, never, never. Doesn't matter if my house is burning down or what's happening, I will never drive 160. Because the risk is not uncertain. I know it's going to happen. So if we unpack it in that format, so risk is solely, real risks are based on uncertainty when you just don't know which way it's going to go. And risk is also what we foresee or what we think might happen. And we also identify risks from lessons learned, 100%. But if it's a new project we're doing somewhere in Africa, in the DRC, going to Congo, we've built a reclaimer for a mine there before. We know they've got political wars, guerrilla wars. We know we face a lot of country risks within Congo, for example. A lot of things we know, lessons learned, what's happened. We ask previous contractors that's worked there. We do our homework. But there is still uncertainty that we face within that environment. And those are the type of risks we usually need to look at, assess, and try and say, well, if it happens, what are we going to do? What mitigations or treatments will we put in place? Before we break, any questions?
Just a question, slightly about the current point. In terms of the certain opera house, did anybody actually do a study afterwards to find out what should the cost have been? Because you said it was a political budget, etc. Did they actually investigate what should the price done?
I've never read up, and you can maybe go and Google it. Google is wonderful. They've never actually said, apart from the original budget that they had of the 7 million, I've never seen any stats or figures, and I've done some quite extensive research on the Sydney Opera House. They've never said, well, in 1957, when we said we wanted to build this, forget about the 7 million, how much should it have actually costed? And I think why nobody really can make that estimation is they had no design. No engineering was even done. They just had this picture in their mind, in the sense that the picture not being how it looks, the picture that, or the idea that it had to be a multi-purpose opera house. That's all they knew. That's all Parliament knew. They just wanted to have a concert hall and symphony hall all together, 2 in 1, 100%. So I think what made it impossible to actually cost what it should have been is that they put it out to the architect and to the market and say, we want a multi-purpose opera house. You come and tell me what it should look like. And then it's free range. Because if it's free range, it's as well as I say, I want you to build me a house. All I know is it must have 4 bedrooms, 3 bathrooms, must have a swimming pool. Just build me a house. One guy's going to build a 3-story or a 4-story house. There's going to be a bedroom on each floor. The other one's going to give me a duplex. The other one's just going to build a simplex house, and it's going to be huge type of thing. And they'll all have different reasons. If you've got big landscape, you might say, well, I don't have to go double story. If we've got a smaller property, we might build up. So it's very difficult, I think, for them to probably have established what the costs are, because they themselves as Parliament never knew what it should look like. Because that design that Joran did from Denmark, that was his idea, and it just won. They thought it looked fabulous, it's going to work wonderful. So they would never have been able to have costed what it would have been, because it was up in the air and anybody could have decided how it looked. The interesting thing is as I was always wondering, how did they make the decision, or what did they base the assessment on? Did they just go on what looked nice? You know, because the guy didn't give him a costing. He just gave them basically a drawing of what it should look like. Yes?
Surely you put a competition out for a concept. I mean, it's like your example of a house. You put it out, say, give me some ideas, and then you select the idea. You don't just wait until folks built it and then go see, oh, what did you build 3 stories? You get like a concept, and then you award the concept, then you start design and detail on that concept.
So that is how projects should run, and that is what they should have done, 100%. But I just want to open up a summary I've done on the Sydney Opera House before we break. And
while you do that, I attended a conference in May where that opera house came up.
yeah,
And there was a discussion or a debate on whether it was a successful project or not. And there actually wasn't agreement. I mean, the artifacts from the project management side were exactly like you put it.
yeah.
And it was a disaster. But when you look at the way it's used today and the general viewpoint of it being an iconic building, there's some sentiment which says it's actually successful in terms of the use today.
So I would probably ask if they measure if it's a success it will be a silly question, is are they charging twice as much for a concert ticket than what they should to try and get costs back? Because if you had an original budget of 7 and you overspent to 102, and it's still not what you wanted it to be from the start, if it's still not intended to be a multi-purpose opera house, I struggle to understand why they would say, and I think maybe why they would say it's not the best project in the world, maybe of schedule and cost, but I think the opera house was quite advanced for its time. Maybe to have said to build those cells and those roofs and that structural design in the 1960s with the type of equipment they had. Remember, they didn't have the bobcats and the machinery and the equipment we have today. That maybe from that point of view I would agree and say, look, the opera house was in the 1960s well advanced. It was way before its time. You know, the whole look of it and the design was advanced. But I can't say I would agree that it was a good project in the sense of time and money. If I look at what the initial idea was, if I just base it on that, nothing more. But I think in the sense that it was a good project is that in the 1960s it was a magnificent building for them to have had. So just referring back, so just basically the history on the design is, so when government called an open-ended international design and they said these guys can enter the competition and appointed an independent jury to do the evaluation thereof, they say the competition brief provided broad specifications to attract the best design talent in the world, did not specify design parameters or set a cost limit. The main requirement of the competition brief was a design for 2 performance halls, one for opera, one for symphony. No parameters, no costing, no idea on design, just saying 1, 2 halls, what are you gonna give me?
I suppose it's probably not wrong to test, just to get some ideas, general ideas. If you stuck on in terms of creativity, but not to formalize on something that's so vague.
100%, and I would ask that if you threw that open checkbook into the market, because nowhere did they say the architect did the costing, it was a political budget. So how did they know it would only cost them 7 million? I'm not saying they're underquoted, they could have overestimated as well the cost there too. So, and that's why we say it's an integrated part between everybody. That if you do have a project schedule and cost, how realistic is it? Is it achievable? Because it's one thing if you ask the client, another thing if you ask the contractor, because they both have 2 separate objectives, 2 separate deliverables. The one physically does it every day, and the client just wants to keep his investors happy, and he just wants to make money off his investment ASAP. Okay, guys, 15-minute break. So basically, we've got more slides left than time. So I'm going to target this one, also latching onto a lot of the questions some of you guys have asked me in the break, is kind of like, how do we cost it? How do we cost real risks? How do we derive at a value, schedule and cost-wise? So what I'm going to do is I'm quickly going to run through the risk and opportunity, the management process, because if you go and look in ISO 31000 or even the PMBOK to a certain extent, you will all pick up on this process flow, and then of course a lot of the things we've discussed in detail already. So I'm briefly going to go through this. If you have any questions, please ask me. But then I want to move over to the quantitative side, if that's fine, okay? So I can show you guys on cost and schedule how we look at risks. So this is how your normal risk and opportunity management process flow would look. So if we go very high level through it, for example, is that the first one you'll always get is you'll say establish the context. Okay? And the context can be internal, external, it can be international, it can be national. So you need to establish a context. You can, for example, use the pestle. So you'll say what political, economical, social, technology, whatever, you can start breaking them down into risks in those various areas, which makes it a bit easy as well. But this is now, I'm not talking about identification yet, I'm just saying those are the areas. So we first need to establish in what context we are looking at it, okay? So there we, for example, have the external factors that could play a role. You have your internal factors, which is basically governance. We spoke to corporate governance earlier on. Your policies, objectives, and the strategies, and how you are planning to achieve them. And then your capabilities. Like, do you have enough money? Do you have the time? Do you have the resources? So do you have the capability of doing this project or what you're intending to execute? And then as well as the relationship and perceptions, values that you have with your internal stakeholders, what's your organization's culture. So before we can identify the risk, we need to know what is the company's objective, what is their strategy, and we do that all when we establish the context. Because I won't know what to identify if I don't know what you're all about, for example. So if I don't know what my business is about, what's our core function, what do we specialize in, what do we do for a living in that sense, how do we know what poses a risk on us? So we need to put it in context first. Then we've got that area, and it's shaded there, and it's called the risk and opportunity assessment. So in the assessment phase, 3 things basically happen. You identify a risk, you analyze it, and then you evaluate it. So if we say often delivered as a standalone, if it's a capability, it needs to improve the understanding. It's usually done prior to program stage gate and establish program contingency. Okay, so in program contingency can be cost or schedule. Cost, monetary value, schedule would be float. And then the 3 key steps in how do we actually get there. Now you guys will note, very important is risk identification, quite straightforward. What do we think the real risks are? We identify them. The most crucial part for me in this whole assessment is under the analysis, because then we start looking at quantitative with the qualitative. So we're not just only focusing on qualitative, that's where we do the quantification of the risks as well. And then of course we move over to evaluation. So basically what does it say when we say that we're in the identification phase? So we're saying that we've identified from the analysis the following. So complexity of cost items with large values. So when we say we prioritize risks, you can do one of 3 things. If you look from a strategy enterprise way, they usually will rank risks, and we'll get to a risk matrix now and explain how that works, is they will usually rank it on what might have the biggest impact on reputation, environmental, revenue, etc. Where from a project point of view, we would usually prioritize risk is what's going to have the biggest delay on schedule or what's going to cost the project the most money, for example. So we need to look at how complex is the cost in the items. And why I say complexity is if I would cost something in a risk, it's not as simple as if I would ask you, how much will you ask me if I buy a pen from you? Pen, one component's got one cost to it. Where if you would sell the pen to me and it's got a little casing that I put the pen in, then the pen, it opens up and it's got a little ink filter. And basically if you sell it to me in 3 components, you could give me 3 prices of it, for example. So if I would come to you, because this is what we're going to do in quantification, I might say to you, well, I don't really need the case. I'm just going to put the pen in my pocket. So I'm only going to pay for the pen itself, no casing. It will cost me less than if I buy the whole package. Now when we start quantifying risk, it's done on exactly the same basis. On a construction site, it's very complex. So if a risk would happen, it will affect more than one area, or it could affect more than one area. So there might be engineering change. Engineering is affected. The engineering change will knock on something in construction, something specific. Will it be civils, mechanical, piping, electrical instruments, whatever? Then if it knocks it on, does it mean we have to do procurement of that material? Like whatever the knock-on is. Do we have spares? Don't we have? Must we go procure? So procurement might be affected, the cost thereof. And then of course, if we would overrun on schedule, there'll still be an overhead cost we will have to cover. So if schedule overruns with a month, yes, we will have a demobilization plan, not only of labor force on site, but from a management point of view, but you'll always keep a certain amount of people on site until the job is totally commissioned and handed over, right? So there'll still be a proportionate costing there as well. So when we cost a risk, we need to cost it in all those buckets basically. Because if I just cost engineering, my cost is going to be too little. But I'll show you how that works in a simulation. That's why I say complexity of cost. We need to understand that. As well with tasks, which is schedule driven and which is posing a threat to your critical path in your schedule. And then we say practicality of assumptions and constraints. So how practical are the assumptions and the constraints that we've made? And then we can do it in various ways. You can do brainstorming sessions, you can do SWOT analysis, you can go from lessons learned from the past, you can go to each individual guy on site and say, well, from a procurement point of view, you work in procurement, what are the risks? You can schedule a risk workshop. So there's a few ways you can kick off a risk identification session. After that, it would be advisable to always update it as a group and don't do it on individual. But sometimes it's difficult to have a kickoff meeting at once. So if you want to start the risk register so long, go to everyone, start compiling it, populating it, and then come as a forum together and sit it. Because what I usually tend to do in a risk workshop, I don't go to individuals, I call a risk meeting. But in order for the meeting not to become 6 hours, because what would happen is you would say, guys, what do you think is a risk? Then either everybody will keep quiet, and I'll say, okay, what problems do you have? Yes. And they give me a list of problems, and actually a lot of them are their risks. So it's what type of language do you use for their understanding? And then sometimes when I say, what are the risks, then one guy would say, this is a risk. And then as soon as that guy has said it, the next guy will be on his back and say, that's not a risk. Because sometimes it's that guy's department. So you must understand the politics and the internal fights. So if you would want to do a risk identification from scratch, what I would advise is I usually just draft up this A3 template. I give them the options of listing 3 risks. What's the risk, what's the cause, and what's the possible mitigation? So we'll always add the consequence in the risk, so we don't look at that separate. And I'll hand these out to the guys around the table, and I'll say, I'll give you 20 minutes. I want you to tell me what do you think is the top 3 risks to this project. Whether it's cost, schedule, I don't want to know what the consequence, I want to know what do you think is the biggest risk on the project. Then at least, firstly, you're getting everybody's inputs, because some guys tend to be more quiet than the others. So sometimes a guy never gets to say he's saying, maybe he's got the 3 biggest risks and nobody else is going to identify. So start it from a risk identification form, give them 20 minutes, gather all of it, and then we start working through it. And a lot of the time, it goes a bit quicker at the end because a lot of the guys will sometimes have the same risks and concerns. And then you start flying through them. So what if you've got a document then to work off when you go back and compile it. And then just from a suggestion point of view, always do it in a workshop. Get everybody's buy-in, know what the integration is, because maybe sometimes a guy will say, this is the risk, and the other one will say, well, if that's a risk, it's going to also affect me and my side. Because then we've got integration, and then we actually have something we don't have a lot of in life anymore, and that's communication. Because then we actually talk to each other. Apart from people not talking to each other at all because of technology. Then you have communication, and once we have communication, there can be transparency, there can be alignment. We're all on the same page type of thing. We don't live in our little silos. One of the things you can use, apart from if you want to start getting the guys to think about what risks they need to look at, you can use a risk breakdown structure. A risk breakdown structure is also contained in ISO 31000. It's a standard risk breakdown structure. If you want to in your company and you write a risk framework and you want to dolly it up, add in things, you're more than welcome, but this is how the standard one looks. So basically just tell the guys, in the project we've got technical, external, organizational, and PM categories, and under them, these could be the various risks that we might face. So for example, external, we've got subcontractors and suppliers and vendors on site, so sometimes we're dependent on them for project delivery, so what other risks are. And within those areas, I can promise you the guys will be able to give you more than 3 risks. So give them the risk breakdown structure and give them all an opportunity to at least voice what their concerns are. Then with regards, and one thing I have to mention is, in the risk breakdown structure, none of them are real risks. It is what is the real risk within that. So what is the risk we face within weather? What is the risk we face within procurement? What is the risk we face with subcontractors? To tell me the risk is the subcontractor or the supplier is not telling me what they're going to impose on you. Okay. Then we need to analyze it. So we need to say, these are the risks we've identified. So what is the likelihood of the risk happening? And then, of course, what is the consequence? And then, of course, the two approaches is we do the qualitative, and then we do the quantitative. Qualitative is usually the easy side. It's the thing we always do, because it's what we talk. Risk, cause, consequence. It's qualitative. It's what we type. It's words. It's things we talk about. Quantitative is physically calculating the contingency, whether it's cost contingency or schedule. And of course, they have to actually go hand in hand, which we'll discuss now when we go into QRA in detail. And your deliverable out of that is usually a risk and opportunity register. Because if you've identified it and you were able to analyze it with a likelihood and a consequence, you can already populate a risk register and you've already got something to work on or to work with. Now, how do you, yes?
So in the original introduction, you defined the risk as a threat or an opportunity. But in the subsequent analysis, you seem to be
risk and
saying
opportunity.
Risk and opportunity.
Yeah. So in ISO 31000 is that if you use the term risk worldwide, people will latch on to negativity, right? It's a threat. A risk is not a good thing, right? A lot of people don't know that risk is actually threat and opportunity. So what we tend to use, and it's called meta language, if you guys want to go and Google it. So in risk meta language, we still tend to stick then with the word risk and opportunity because people just understand it better. If I would tell you risk management is threats and opportunities, you're going to be like, well, I thought risk management was just sorting out all the problems we have on site and all the negative things, etc. So it's just and you can go and Google it, it's very interesting, is risk meta language and why we use the word risk and opportunity, even though in risk it has already opportunity and threat. So it's a very good question, 100%. But for better understanding, we go risk and opportunity. And funny enough, they also set it out that way in ISO 31000. So if we do qualitative analysis, so how do we do qualitative analysis? Because now we also need to make sure that when we do qualitative analysis, we do it proper. So in qualitative analysis, we need to establish, like we discussed before the break, what is the real risk? Because apart from you not maybe mitigating the right causes, which means that if you haven't identified the core or the real risk, you're going to mitigate kind of the wrong thing. And the chances of that risk actually materializing, because it's in there somewhere, you just don't know exactly what it is quite big. The other thing around that as well is that if we don't identify the real risk, so we don't really know what mitigations to put to the causes to try and mitigate the risk, is how do we cost it? How do we know if the costing is accurate enough? And I'll use an example again of those previous ones, that if we say the real risk is inclement weather, and I need to mitigate the causes, how do I cost it in schedule? And how do I cost it in cost? So what I'm trying to say in a nutshell is that a real risk is detail, if I can put it that way, if it makes more sense. Inclement weather is a broad statement. Cost is a broad statement. Injuries and fatality is a broad statement. It's specifics, details. Because the more detail you have, the better you can cost it and allow for it in your schedule. And this is why I usually challenge most of the estimators and the planners is estimator will thumb suck 10% of contract value. That's his contingency. Very interesting. And they'll build in float. How they establish float, it's also debatable. So when we go to quantitative, you guys will see that sometimes I get called to a project and I'm not asked just to do project risk management, I'm asked to assess the planner's schedule and tell me what's the integrity of the schedule like. Does it have too much float in it? Does it have open-ended activities, etc., etc.? Because as soon as I start analyzing that from a risk point of view and perspective, you pick up on a lot of things, and I'm going to show you why and how we do that in the quantitative side. Same with costing. How do I know if a guy is maybe overcosted or undercosted it? Because it's an estimator's forte. They specialize in that. But we must also remember that these guys don't always take risks and certain conditions into account. And that's where we come in. We the project risk team, we're the contingency guy. We're the guys saying, guys, this is your get out of free jail card, which it actually is. People think a risk register is a swear word. Is we're saying that if you have a risk register, you've costed it and you've scheduled it. So you don't have a P0 cost or a P0 schedule. You've got a P30 date. Let's say, example, you build in 30% float and 30% contingency. But now I can back up my 30%. If any auditor or exco member comes to me and say, well, you've costed 20 million, where did you get it? I'm going to say, well, all these risks, just these risks. If any other risks happen, I don't have contingency for it because we haven't identified it. These ones I've costed and scheduled for. Then if something happens and we overrun on budget because of one of these risks, they can't turn around and say, you guys never told me. And so, well, we flagged it 6 months long in a board exco report, and now it's gone wrong on the project, unfortunately. So you'll get out a free jail card. It's the project team at least advised us that it could happen. Then, when we do qualitative, we need to have, they call it a risk matrix. So actually the right-hand little block with all the colors, that's actually the risk matrix in itself. But what feeds into that is a likelihood table and a consequence table. Now there's no said or hard and fast rules around what your likelihood table should look like, or your consequence one, or what your risk matrix should look like. So this is a 3x3 risk matrix. You can have a 3x5, 5x5, even a 5x7. I've seen some companies that have a 7x9, which is, that is quite detailed. The bigger your risk matrix is, the more accurate your analysis is in that sense. Because if it's a 3x3, I'm just telling the guys around the table, it's a low, medium, or high risk. We're going to thumb suck again. If I give them 7 options, they're going to start thinking, well, I need to think about this. I never base a risk matrix on low, medium, and high. What's your definition of low, medium, and high? So you can maybe tell me if we have one fatality. If we have no fatality, it's a low risk. One fatality, it's a medium risk. Multiple fatalities, it's a high risk. But it's not really giving me very accurate information. So what we need to do is sometimes we need to assign a percentage to it. So we'll say if it's a high likelihood of it happening, it means it's between 66 and 100% chance of happening. Now on a 3x3, that is quite drastic, 66 to 100. So I'd rather break it down into a 5 or a 7 risk matrix so your percentages are much closer to each other. And please, never give the guys a 50-50 option. All your risks would be 50-50. We'll all sit on the fence, and we'll either happen or it won't. So I've never in my life presented any project team with a 50% option. And it quite fascinates them. Because sometimes they'll be like, what's the likelihood? They'll all go, oh, it's 50. I said, well, you don't have a 50% option. So you have either a 35% chance of it happening or 75. And then the guys start thinking, they go, well, if I say 75, I'm kind of saying we're in trouble. If I say 35, I'm actually not really flagging it because it is quite a concern. So sometimes they'll peg it at 75 and say, look, we don't think it's quite that high, but 35 is too low, so we need to make sure we do X, Y, and Z so it doesn't happen. So very important is, what do you base your likelihood and consequence table on? How is it established? What's the percentage assigned to it, etc.? Because that is what we're going to use to do a quantitative risk analysis. Then we roll over into quants. So we can only do a quantitative analysis if we've done qualitative. Because in qualitative, I'll ask you what's the likelihood and what's the consequence. So you can have two quants when it comes to costing. You can either base your risk register on pure cost or on schedule. So for example, if I would say cost, I would say if this is the risk and this is the chance of it happening, what's the minimum, most likely, and maximum cost impact we could face if this risk happens? You might say 1 to 3 million. So it's 1, 2, and 3 million rand. Just high-level ballpark figure now. So, okay. Then it will run the simulation on those likelihoods and those various costing scenarios, which I'll explain in a bit more detail. Second risk register, quants, is if I need to work out the costs, is I will say, if this risk happens and this is the likelihood, what would your impact or overrun on schedule be? If we talk weeks now, for example. He will tell me, well, it could be between 2 and 6 weeks, we're not quite sure. So let's peg minimum 2 weeks delay, most likely 4 weeks, maximum 6 weeks, and then I'll show you how do we derive a cost in costing that as well. Because people would always say, but how do you cost schedule? And it's very interesting. So if I was to have to choose, I'll always use a schedule risk register. Because what it does is it gives me schedule impact and it gives me cost. Schedule analysis we do in Pertmarvit STIP and Primavera risk analysis, which I'll explain how we do that. But if we solely look at a risk register in which we've identified likelihood, etc., if you could assign time to it, because time is money, it will be very beneficial because then you'll have time and cost impact in one risk register. And you can choose how you want to rank it. You can either show the priority risks by saying, what are the risks that will pose the biggest threat to schedule? Or what are the risks that will pose the biggest threat to cost? Because it's not always to say that the one that's going to cost you most in time will cost you most in monetary value, and vice versa. And we need to understand that as well. So we need our qualitative risk register in order to latch onto quants. Then you need, so the software we use, so for quantification risk analysis, we use @risk. It's based on a Monte Carlo simulation. It's quite complex and sometimes very difficult to understand, but it has a lot of logic behind it. It's very, very accurate. Sometimes when estimators are out, they say, well, our costing might be out between 5 and 15%. I can always guarantee you a Monte Carlo simulation will be a lot closer to what the actual impact would be. And I'll explain to you why. It doesn't contain airy-fairy thumbsucks. It contains the cost engineer's costing. It contains the planner's schedule. So if you're telling me this is your budget, these are your areas, and the planner is telling me this is the schedule, and I do a risk assessment and the team is saying, well, we face these likelihoods and impacts, you can't get a closer costing to it because you're running your simulation of actuals, which I'll explain to you guys a bit more detail as well. And then we use Primavera risk analysis. Yes?
How accurate is that analysis? You know, once you finish the project and you've done a post-mortem, you found that if there has been risk events that have occurred, has it been pretty accurate?
So out of my experience, and I'm just telling the projects I've worked on, unfortunately, it's never come to that stage where we've either didn't spend all the risk budget, or it's never come to that point where we said, well, it was so accurate that we actually had a cost saving. But what it has done is it has said that for 3 months on a project, we flagged X, Y, and Z. The sad thing is all of it materialized. So funny enough, I worked on a project. In 2012, and this is a prime example, and that's why I say it's very accurate. I'm going to tell you why. The project director comes to me and he says, Charlene, faced a lot of risks. This is our end date. This is what we've promised. I need you to do a risk-loaded schedule because I'm not quite sure. I'm not quite sure about the contractor schedule. I'm not quite sure about my own planners updating it, and I don't know if we have enough money. Can you do a risk-loaded schedule? We've got a risk register. Let's just update it. Let's see what activities in the schedule we're going to link to it, and tell me when we're going to finish. I said 100%. Sat with the planners, sat with the cost engineers, sat with all the team members. We did a proper evaluation thereof, and then I did a risk-loaded schedule. And then I said to him, well, which date would you want? And he said, give me a P50, because I told you the 50% guys love 50%, right? He says, give me the probability if it's a 50% chance that we will overrun, what would my date be? And I said to him, you'll finish in September 2015. He nearly fired me that day, I have to say. He nearly kicked me off site, back to TNT office. And he said, the first thing he actually said, and he didn't mean it any rude, he said, are you crazy, woman? Well, no. No, I'm not, but okay. Funny enough, to prove the stats is, I do schedule risk analysis with the costing every month. It's just part of the report, so we can see if it pulls back or, because sometimes it will show that it's pulled back on dates, it hasn't always slipped. And it will never always be 3 years drastically, depends on what risks they were facing. Actually, to this date, so 13th of October 2015, that project's still not done. So 3 years ago, I told the guys, well, if you're not doing anything about it, and we're just talking about it, and we all know what risks are, but risk isn't going to save you. It's what we do about them.
Your analysis is also based
Still
on
not
accuracy
done.
of the information that you get.
And that's why I would interrogate. So yes, 100%. Well, if I would, for example, at the cost engineer, if I would go and see the cost engineer, I would say, what was the original project budget, right? What did we receive to start the project? And he'll say 3 billion, for example. So, okay, how much do we have left to spend? And he's going to say 2 billion, okay? Let's say original project duration was 3 years. So let's say $1 billion a year was the distribution, just to make it easy. And I say, okay, what's the forecasted time to complete now? And he's like, well, we're going to take 5 years. So already we know 2 billion, you know, for another 4 years, it's not going to be enough. So now I'm working on actuals, right? It's actual things. These are the things that we report to board. Now, the schedule, yes, 100%. I'll question what's the integrity and how valid is the information that they're giving us. Because it can actually not be another 2, it's going to be another 5 years for all we know, because we know how contractor schedules work. But from a costing point of view, it's how much money did we have, how much do we actually have in the bank. And then, and I'll show you guys how it works in a costing model, is I will say, and let's use a construction project as an example again. I'll say, well, we have civils as a discipline, right? We might have structural steel type of work on site. We might have electrical and instruments. We have engineers that we need to pay. There might still be procurement items, and let's say we have a project management team on site. Your contractor's P's and G's is calculated, for example, in the civils, the E&I, the areas and the disciplines that they work with, okay? So we cover their P's and G's as well. And I'll say to you, so how much do we spend a month on, let's say, civils, for example? And let's say it's 4 million. So weekly, we spend R1 million, okay? So if we would delay civils, for every week we delay them, it could cost us R1 million, right or wrong? Depends on who's to blame now, but let's just say civils will stand for a week. We physically spend R1 million a week for them to work, right? Now, if there's downtime, and they are still entitled to a claim, for example, it will cost us R1 million for every week that civils is delayed. However, the whole civil site won't be delayed, right? It will just be a portion thereof. So in the quants, it will take into account what's the likelihood of the risk happening, what is the possible weekly overrun that we might face, right? What areas will it affect? Let's say civils is one of them. And then this is where a guessing usually comes in, is that what percentage of civils will be affected with this risk? So if it's rain or civil strike, it will be 100%, the whole site, nobody will work type of thing. But let's say it's just one of the buildings and we can proportion it to it's 5% of the civils bill of quantities, it's 5% of what they need to do, then 5% will be delayed. So what the simulation will do is it will say for every week, and let's say we've said most likely 3 weeks will be delayed. So it's a simple math. You'll say 3 weeks multiplied $1 million a week is a 3 million impact, right? On the 3 million impact, what's the likelihood of it happening? Well, let's say 50%, just to make the math easy. 50% chance of that happening. So it's only 1.5 million that we face, because we're not saying the risk is definitely going to happen. We just want to proportion it. And then on the 1.5 million, what percentage area is affected? And let's say we tell it 5%. Your impact is 75,000. So the only thing that you can sometimes question is how accurate is the proportion that we've assigned to the affected area. But the cost is tangible, it's a real thing. It is what we physically pay the civils guys for every week, that whether they work or downtime, that's what they usually cost us on our site. So if we would overrun on civils with a week, with those likelihoods, it will probably cost us that much amount of money. Does that make sense?
So then how often do you take a risk analysis on a project? Because at different stages there's different information available. And the accuracy is obviously good. You look at the Sydney Opera House. At the beginning it was a concept. 2 years down the line, it's very different.
So we usually run through a project life cycle. So we usually like to start in its in inception phase. That would be the ideal. Sit in our container, you run with our guys. Our sites run bi-weekly risk workshops. So every second week the guys come together. We assess the risks, we run the quants again on cost and schedule, and we see what drastically has changed and what has not. Because that's also the best way you can try and mitigate something. That if we say yesterday this event happened, or we're aware of it, what are we going to do about it? We can still do something. Otherwise, in a month's time, you have a risk workshop. Some people think you should only have one quarterly. In a business, it's fine, but not in a project environment, because every day things change, right? Then that risk would have impacted your schedule and cost a long time ago, even before you started thinking what you could do about it. Now, the ideal situation would be if we could beforehand have identified it, because then it happens, then we say, okay, we're going to say this guy is going to do X, Y, and Z, the risk owner, and we've got it under control. The things we face these days are the risks that if we didn't do a proper risk analysis is that things are happening that we've never even had in a risk register. We've never considered them, we've never looked at them, and now all of a sudden, in that point in time when it happens, they say, well, what do we face? And we're like, well, we're not quite sure because we have done no assessment around it yet. So in a project construction environment, you have a project risk manager sitting on your side every day. They should be part of your project management team. Not all contractors and clients work on that point yet, because they will always say, yeah, but it's a PM's responsibility. I understand what PM Box is, and I understand if you do your PMP exam, but the project manager will never cost it, right? He's going to think, well, it might cost me this much money or schedule overrun, but he's got a million other things on his mind. That's why that's one of the key components of your team, is having a project risk manager running and just doing this analysis all the time and saying, in this environment, if you keep on going this way, this is going to happen. And that's the same projection I did for this guy. And all it proved was that a lot of those things they just never looked at. They knew what they were facing cost-wise. I mean, basically their budget has gone from 4 billion to 30 billion already, and they're still not done. And then if you go back in the day and all the risk forecast we did, month after month. And the first thing, you'll notice what happens, is if cost overruns or schedule, the first person they call in is the risk manager. We say, what the hell's going on? Well, we're overrunning on cost and schedule. If you have a good project risk manager, they'll say, yeah, but we've always told you that you're going to face this, or you might face it, because we're not doing all these things, or we're not addressing these things, or we're not addressing them properly. Those are the type of things that can happen. So from an accuracy point of view, it's quite accurate, because sometimes I think if they only looked at the stats or the logic behind it, why did we say they were going to overrun on cost? Why did I say we were going to be 3 years late? Because surely I can't thumb suck something like that. Because the exco and board members will shred me to pieces. Because I usually go and present my risk stuff to them. Because the project team's not always sure how the calculation's done. They'll say, and when they did ask me 3 years, you're out of your mind, like what? And the valves was a prime example. I said it takes 40 weeks for these valves to get into the country, right? You're supposed to install them in 2 months' time. So nobody ever told me it was a risk that the valves were never ordered. Then all of a sudden, somebody woke up and they said, oh, when we did our monthly look ahead, 2 to 4 week forecast and schedule, we picked up, we need to start installing these valves. We don't have valves, we need to order them. Now this whole commercial process started. Now 40 weeks, I told you, was only for the X-Works. Go out for 3 quotes, place an order, etc., arrive on site. Now there's things we can do. We can put in spool pieces, cotton reels. So we won't let the flushing and the hydro testing stand. But we must remember a spool piece is designed on a drawing as well. So if we don't design enough spool pieces, some of those pipes we won't be able to hydro test. So those 40 weeks just compounded, and all you do is you face another strike season, you face another rainy season, you face another builder's break. We all know in December you lose between 4 and 6 weeks. Shut. Even if the guys come to site. I've never worked on a construction site where the skeleton staff was 100% productive. I mean, it's just not the way it works. So a 40-week lead time item, which was supposed to have been placed long before, delays the schedule with 3 years. And that's why I said it has to have logic. You have to explain it. You have to explain to them why you're saying it's that time and that cost. So from a schedule point of view, why I would interrogate a schedule before I would risk load it is if it has open and ended activities, it would run the date. It won't have any end date. It will show, it throws out this funny hash sign. It just can't establish a date because it doesn't know where the MC or the commissioning date is. It doesn't know where it has to finish. So it will just run into eternity. As well as I will pick up with a risk loaded on schedule, I'll pick up how much float it is. So if I say it's a 10-day delay and there's 5 days delay in the float, it will just push out that activity with 5 days. It won't keep the 5 days float and then attach another 10 days. It doesn't make sense. It's got a lot of logic around saying, well, you're telling me it's 10 days, I've got 5 days on my float, it's only going to impact 5 days. But if those 5 days don't have a direct knock-on, it's a parallel activity, and it stops there, and it's not either driving your longest or your critical path, it also won't move your date. But if it is a driver to it, it will shoot out your date. With how much, I won't be able to tell you until we do a physical assessment and see how accurate it is on that schedule. And then you can look at mitigations like, what's the productivity percentage we've assigned to the schedule? 90%. Okay, Mr. Contractor, I've never worked on a site with 90% productivity, so it's inaccurate. Then I'll go back and say, drop it to whatever the trend says, that you've never been more than 60% productive on the site, so you drop your schedule to 60%, because then the date would run automatically, right? Their schedule will slip then if they start building those things in, the accurate ones from their side, and then do a risk-loaded schedule. Then the overrun won't attach it to the end date, it will just put it in where it's supposed to be. Same with resource loading it. Same with how many days do you work, how many hours are you on site. Because if you work 7 days a week, 10 hours, you don't have much time for recovery. Where if I link a risk and I say the mitigation is we'll work Saturdays and Sundays, because it's only a 5-day work week, then you might not impact your schedule at all. There might be enough recovery time within it. So it doesn't just look at risk, it look at the float within the schedule and the mitigations we have to our disposal. Does that make a bit more sense? But let's go to the quantitative, maybe we can. So guys, the rest is just evaluation, treatment, monitor and review, and then communicate and consult, and how we roll up the risk registers into board reports. But I'll send you guys it. You can go through it. Like I said, it's aligned with ISO 31000. It's just the sad story about risk contingency. So brave project managers don't need contingency. Estimates are fact, they believe. They're 100% covered. They don't need any money. They'll fly it within that budget. And then we hide and bury contingency and estimate details because we fear we lose it. So what these guys do at estimating phase, they say, no, we've allowed for contingency within the estimates, which we all know it's standard practice. That's what they do. But because there's no logic behind it, no specific risk that they've actually costed it and how they costed it, I've never heard that contingency and the estimate was enough to save a project, unless you guys maybe know of a project that was done, because it's possible. But I've never heard of a project that the estimating had enough fat in it to save the project, contingency-wise. Then they always think the contingency belongs to the senior VP, and we projects have no control. So we can't decide what we need to pay out of it. Vice President, he has the sole right and say over it. And then contingency has a bag of slush fund that nobody knows the details. So we've got 100 million there, and basically what they say is first come, first serve. Doesn't matter what happened, whether we identified it as a risk or whether it was built in estimating phase, whatever happens, even if we have a social party, believe it or not, we will use the contingency for it because we have lots of project money. So it doesn't go for anything specific because that cost was never based on anything specific. So you don't know where to apply it and how to apply it and what's the logic behind it. Then they say we use contingency to cover overruns. So what happens usually in a contractor's environment is contractors starting to overrun, and sometimes we don't go the commercial road, which we're supposed to go. Then we say, well, we just pay the contractor every month, right? He's actually slipping, you don't meet some of his milestones, whatever contract we have, there will be different reasons. But now we just pay. Then, 3 months before we run out of budget, we say, oh, we've got another year on the project left, and we've got 3 months. Now we want to hold the contractor liable. Now we want to impose penalties. Now we want to disallow costs for defects and rework on site. And now everybody's in a hustle and bustle because we never applied it the correct way. In the second month, if rework was done, and I should have disallowed it, I shouldn't have paid it. But because it's this big bank account, and we all know that's the way, the nature of projects, which shouldn't go that way, it just does. We just pay out of it until we start running out, and then we go, what are we going to do now? And sometimes it's a bit too little, too late. And then that 10% thumbs up contingency, which the estimators always come up with. I love discussions with estimators, it's like with engineers. I find them fascinating. So I usually challenge the 10%. And then what do we say if we say, what do you mean we cannot advance contingency? The project manager says it's okay. The project manager says we can draw down, there's contingency money, we're just going to draw down on it. Well, if we did a proper risk analysis, we would know what that contingency is for. And we can only apply it if that happens. If anything outside of that happens, that we never identified as a risk or quantified it, we're actually supposed to go to board or to the investors or to the shareholders, or if I'm the contractor, go to the client and say, look, posing this risk on me, this is going to happen, I'm not going to have money, let's pay it. How are we going to pay for it? Contingency drawdown follows cash flow and not execution schedule. So what it means is if we do a drawdown from contingency, in the risk management plan that you're supposed to have, it should say that you will follow a project controls notice, which will give you the right to do a drawdown. Project controls notice will say, this is in the risk register, it's been identified, I need X amount of contingency to pay for it. Because what contingency goes for is mainly schedule overruns. So then what you're actually telling me is you have one real risk according to you, and that's schedule overruns. And I don't know what to mitigate because I don't know what's causing your schedule overruns.